Welcome everyone to another learning session. In my experience, many companies these days are multi-cloud. At least they'll have a backup plan if they want to move to other clouds. If their relationship with the current vendor gets damaged, or the other vendor gives a better package, a lot can happen, right? And in this multi-cloud world, you need a multi-cloud provisioning tool. That is where a tool such as Terraform becomes very significant. One thing I always tell my students is that if you want to really excel, then you have to put some effort. And that effort is not just watching the sessions, just like watching a movie with the popcorns in hand. You have to practice it. And in my experience, if you practice these things, you will be able to clear any interviews with much ease. And if you don't practice, even if you have learned everything, there are good interviewers who can make it out. They can just confuse you, and you will get confused if you don't practice. Any company you go and work these days, they'll be using Terraform, 90% or more. Whether they are using AWS cloud or whether they are using Azure cloud or GCP cloud, they will be definitely using Terraform. From a job perspective, this is a very important skill set, not just for DevOps engineers, even for administrators. Many people cleared interviews from C1 group recently, and most of them, even for administrator interviews, they were telling they were getting questions or smaller problems to solve in or using Terraform. And for the groups, I'll be sharing the lab materials also, but you'll have to follow and complete it. I've organized it in a much simpler way so that you can practice and learn one step at a time. But if you are not practicing, it will be very bad. Because for normal sessions, so normal Microsoft sessions, it is very easy for me because Microsoft has prepared all these labs. But for Terraform, I am personally preparing all these labs for you to practice. You have to just follow and then do it. Okay, and maybe in future, I might convert it to a book also, and whoever is actively participating and providing feedback for improvement can be a part of that book also. Okay, Terraform through practice. So this is a tech series for Terraform in which you will be learning through hands-on recipes rather than just from theory classes. Normally, we will have a lot of theory, and then the instructor will be doing the lab on screen, and then you'll be watching it just like a popcorn movie, and you will go home and then rest. But here, while doing the lab, I have taken almost all screenshots and prepared a very good lab document. I believe it is good, and then if you can provide suggestions, we can make it better. All you have to do is understand the concepts better and then practice it following these lab documents. And the team is always ready to help you with any doubts in our community groups. All of you are part of the community groups, either by a membership or by complimentary access for Forum CA. And our members, as well as trainers, as well as core team members, most of the people are there ready to help you. All you have to do is practice, ask doubts, and complete it. What is Terraform? If you look into the definition of Terraform from Wikipedia, Terraform is an open source infrastructure as code software tool created by a company called HashiCorp. Users can define and provision data center infrastructure using a declarative configuration language known as HashiCorp configuration language or HCL, or optionally JSON. There are also some other versions of Terraform, such as Terraform Cloud and Terraform Enterprise. In this session, we will not be focusing on those variations. we'll be focusing more on the core Terraform open source product. Okay, let us take one thing at a time. Infrastructure as code. What do you mean by infrastructure as code? Earlier in the software development lifecycle, your developers used to develop code, then gives to QA or quality control, and then it is given to the deployment team or the production support team or whatever name you want to call. And they will have their own scripts that they manage, and finally they will deploy it using those scripts or by running some commands from command L and all. But later, many provisioning softwares or tools came. These tools or software could help you provision your infrastructure, and it will avoid a lot of repetitive work. Some of these were pure provisioning tools. Some of these were configuration tools that could help in provisioning. Tools such as Chef, Puppet, Ansible, which is still there. Cloud providers created their own versions or their own variations of infrastructure provisioning tools. For example, AWS has CloudFormation, and Azure has ARM templates. And still people wanted more, people wanted multi-cloud. That is where something such as Terraform becomes more important. Okay, so Terraform is not just multi-cloud, it has much more reach rather than just cloud. In today's class, we will see a lab that uses Terraform to create a repository in GitHub. The reason I wanted to put this example first was because you already had your Git 101 session and you are comfortable with Git. And second, I wanted to make it clear that Terraform is not just a tool for provisioning cloud infrastructure. You can use Terraform to provision a lot of things, Docker, Kubernetes, and a lot of things. So once we have sessions around Docker, Kubernetes, and all, we will also have corresponding Terraform sessions for using Terraform to provision Docker, Kubernetes, etc. And we will also have Terraform provisioning for Azure Cloud, AWS Cloud, and a lot more. So this is one tool, one very handy tool that can become very useful for DevOps engineers as well as those multi-cloud architects or future architects. Infrastructure as a code is something that allows you handle your infrastructure provisioning logic just like developers handle code. That was one of the reasons we learned GitHub and Git and all or most of the variations of them. Earlier, there was this belief that GitHub is something that is only for developers. Yes, DevOps engineers pick up some code from GitHub and then they deploy it using pipelines, something we will learn a lot in the Azure DevOps sessions. But now with infrastructure as code, even DevOps engineers will be using these source control systems such as GitHub or Bitbucket or GitLab, just as developers use. Because with infrastructure as code, your infrastructure provisioning logic is now put as code, and that can be code reviewed just like the normal code is reviewed, maybe by a senior or somebody who is approved to do that. And only once all those processes complete, it will be getting merged to the main branch or whatever branching strategy you follow according to that. And then users can define and provision a data center infrastructure using a declarative configuration language known as HashiCorp configuration language or optionally JSON. So what do you mean by declarative? How many of you know the difference between declarative and imperative? Okay, declarative means you are just telling what you want without explaining how to get it. Our recipes for cloud that I am preparing, or even a normal cookbook with the recipes that you can use in a kitchen, all will have some steps, right? You do this one you do this one, step 2, step 3. There will be a detailed set of steps. And then once you follow it, you will get the end result. And declarative means you will not provide the steps. You will just tell, okay, what you want. For example, in our lab, you will be telling, okay, I need a GitHub repository to be created. Behind the scenes, you are not worried how the repository will be actually created. Similarly, you can tell, I want a virtual machine to be created. You'll be also providing the parameters and all, but you will not be telling how that virtual machine needs to be created or behind the scenes logic. In the case of GitHub, behind the scenes, Terraform might use simple APIs. And in the case of AWS, it might behind the scenes use CloudFormation templates. And in Azure, it might use ARM templates. You are not worried about these things. You are just telling what you want. And rest all is taken care by Terraform. And that is the beauty of a multi-cloud product such as Terraform. Some of the alternatives, AWS CloudFormation, Azure ARM templates, and products such as Ansible, Puppet, Chef, etc. Ansible, Puppet, Chef, etc. are mostly products that can help you in configuring things. And many people these days use a combination of Ansible and Terraform, but it is not a necessity. You can manage with Terraform alone. And some of the important features of Terraform, and some of these are features of any infrastructure provisioning tool in general. First one, infrastructure automation for idempotent, consistent, and predictable environments. How many of you know the meaning of the word idempotent? Yes, Jagdish. Giving the same result in spite of repetitive execution is idempotent. For example, I have a mathematical statement, say a equal to 1, and I am doing a equal to a plus 1. So when I execute it, what will be the result? First time when I execute it, a becomes 2. Second time when I execute it, a becomes 3. Third time, a becomes 4. So is it an idempotent operation or not? Okay, it is not idempotent. Consider another statement, C equal to 5. If I execute it 5 times, the result of C will be still 5. So it is safe to execute it multiple times, and hence that is a idempotent operation. When it comes to HTTP, there are different HTTP methods like put, post, delete, get, etc. And out of which post is supposed to be not idempotent, and rest all are supposed to be idempotent. I mentioned supposed to be because whoever is implementing still can make it the other way. We'll not go deeper into HTTP and REST. We will have a session on it if people are interested. Okay, coming back. So idempotency is an important property of Terraform. Even if you execute a command twice, Terraform will not go and create the infrastructure twice. Okay, it will know that, okay, there is no change from what I have created before, so I will not create it again. We will see the detailed steps soon. And consistent and predictable environments. Whenever you are doing things on your own, manually, by running commands, you can definitely make mistakes. Because we are humans. Humans can make mistakes. Those are called human errors, right? But when we have a template, we have these scripts that are verified to work in one environment, then the same script can be used to provision resources in any environment. And its behavior will be consistent, and it provides us with predictable environments. And as I mentioned before, this is defined as code and stored like code and can be managed like code with all the things that developers do, code reviews and all those things you can do here also. Then declarative syntax, basically say what you want without providing the steps. Imperative provides the steps to get it done. Here we use a HashiCorp configuration language or JSON. And another advantage of Terraform is that it is a push-based deployment. That means you don't need any agent to be running on your providers and pulling data from the provider and then updating through that agent. It is a push-based deployment model. And as all of you know, it is cloud agnostic. It can work with the private clouds, public clouds, and even other products which are not cloud. And reusability is a feature of any infrastructure provisioning tool that can be stored as code. We can use the scripts again and again for similar deployments, which is related to point 1 again. And finally, you can modify or update infrastructure with ease. If you want to make an update to your existing infrastructure, you just have to update your scripts, and Terraform will try to understand what is the newer changes, and it will only update those newer changes. It will not update everything again. And then Terraform Cloud, it is HashiCorp's managed service offering. Manages Terraform runs in a consistent and reliable environment instead of your local machine. It securely stores state and secret data and can connect to version control systems also. The Terraform Cloud UI provides a detailed view into the resource managed by a Terraform project. So many things are managed for you. You don't have to configure all these things in your local. But anyway, we'll not be looking into it right now. We'll see it later. And then there is this Terraform Enterprise. It is HashiCorp's self-hosted distribution of Terraform Cloud. Offers enterprises a private instance of the Terraform Cloud application with no resource limits. Support additional enterprise-grade architectural features like audit logging and SAML single sign-on. Again, something we will see in future. But first step is to understand Terraform in and out. So when you start learning about Terraform or start understanding about Terraform, so these are some of the key terms that you should be learning, keeping in mind, understanding, and then using it across. Terraform executable, you need to have the executable in your machine. If you are executing it from your local machine, we will see how to get it done. And then you have configuration files, which are the main thing. So where you'll be actually writing your logic. You'll be writing things such as what will be your provider. What is a provider? So here a provider can be AWS, provider can be Azure, provider can be GitHub or Docker. The idea is that you specify the provider and then use the same sets of commands. In the next slide, we will see what are those commands. We will use the same sets of commands, but behind the scenes, Terraform will be using different provider plugins to actually talk to those respective providers. Terraform also manages your state, the state of the server with it, so that whenever you make any changes, it can compare, okay, these changes are new, so I'll need to apply only these new changes and not everything else. There are cases where you actually provision through Terraform and then you manually make changes in the server, even though it is not advised. And there are solutions and workarounds and all those things for that case, but we are not going to look at just right now because that will complicate things. And resources are you actually what you actually create. Maybe a GitHub repository or a virtual machine or a virtual network. All these are resources. The resources will be different for different providers. Then you have data sources and modules. We'll not be looking into data sources and modules in the first chapter. We will see them in upcoming chapters. Modules are just a way to group configuration files. So for this chapter, you need to understand what Terraform executable is, configuration files, provider plugins, state, and resources. Okay, and then 5 commands we need to keep in mind before you go further. First one is Terraform init. So this Terraform init command, it initializes the working directory that contain Terraform configuration files. What is a working directory? You'll be working with the Terraform in some directory, right? Some folder in your local machine. That folder or directory is your working directory. So initially that directory is just like any other directory. But once you do this init command, the directory will be initialized for working with Terraform. And one of the things that it does is getting the provider plugin information and plugin things. So basically, you will be running these commands for Azure or AWS or GitHub or Docker or Kubernetes or whatever provider you are working with. But behind the scenes, these provider plugins help Terraform in converting these common things into some form that is understood by your provider. Okay, so that provider actually abstracts away some of these imperative things from you so that you can work in a declarative way. So init is about initializing that folder. And then FMT for format, it is an optional command. People like me feel happy when the code is structured and formatted correctly as per the conventions. Terraform format command is used to rewrite your Terraform configuration files to a standard format and style. The command actually applies a set of Terraform language style conventions along with some minor adjustments and all. Basically, the goal is better readability in a consistent way, but that is completely optional. The next two are very important: Terraform plan and Terraform apply. Terraform plan, it will create an execution plan for you. It will first analyze what you want. It will compare with what is already there in the server. And then it will tell you, okay, so these are the things I am going to do. So it will provide you with an execution plan based on whatever you have configured in your configuration files. Okay, and then before these important commands, there is a very important step that I have not mentioned here, which is creating your configuration files. All these things does not make sense if you don't have any configuration files, right? So we'll see that. So plan will give you an execution plan. You have two options: either watch it and then go ahead, or you can also save that execution plan into a file, and then you can use that saved plan later. If you are running a Terraform apply command, what Terraform do by default will be, first it will create a execution plan again. So if you have run a Terraform plan before, and if you are running this apply, so Terraform will again create this execution plan. Many things can change in between the time you run the Terraform plan and then you run apply. So Terraform does not give you any guarantee that whatever was there in the execution plan before when you ran plan will be the same execution plan now. So what Terraform do is, it will provide you that execution plan and it will ask for your confirmation. It will ask, okay, I'm going to do this. Can I proceed? And then once you say yes, it will go and apply. Apply means it will create that resource or modify the resource, whatever you have configured in your configuration files. And there are also ways you can skip that prompt asking you for permission. You can use a flag called auto approve to skip that. And another way is to use a saved plan. So if you have saved a plan as part of a Terraform plan step, you can use that saved plan. Then also it will not ask for any confirmation. And finally, you have a Terraform destroy. Terraform destroy is for destroying the resources that you have created using this configuration file or set of configuration files. In production, we rarely use a Terraform destroy because most of the provisioning done for production generally are long-lived and run for a longer period of time. But it is very handy whenever you are working on your development environment or whenever you are learning like you are doing now. It is good to destroy all the resources that you created so that you will not be charged, right? And even when you are doing some POCs and all. But in production, we rarely use it, and you should always use it with caution. Okay, so this is going to be a different session. Along with this, I'm also planning to prepare this as a book. So if you have any feedback while going through this, you can let me know. And whoever is providing regular feedback, like my last book, I will include your name in the book when it is published. So last book was published by Pact, and it is available on Amazon, O'Reilly, and all major platforms, and even won the award of best 8th cloud computing book of all time. And whoever was part of it from starting till end have their names printed in the book. So this is an additional benefit you can get by just learning and giving feedback. Okay, and then please do not share it with anybody else. It is shared with you, and once it is ready to be shared with others, I will let you know. Okay, so chapter 1, it is getting started with Terraform. We have some theory again to read through, basically about infrastructure as code, and then declarative, imperative, and all the things that we discussed. And some of the advantages of Terraform, including Terraform can work with Azure, AWS, and many other cloud providers. It has got many providers to work with various cloud and even non-cloud resource provisioning. We can do parallel provisioning, taking dependencies into consideration. We can preview changes that will be applied to the infrastructure. So that is a very good thing, right? That previewing part, even before going into applying the changes, you can see what is going to happen. You can see the future and decide whether you want that future or you want a different future. So these are the recipes I have added now. Installing Terraform manually on Mac machine, working with Terraform using Visual Studio Code, and integrating Terraform and GitHub. And if you are on the way, like installing Terraform manually on a Windows machine, installing Terraform manually on a Linux machine, working with Terraform using IntelliJ IDEA. Some people, especially from a Java background, prefer IntelliJ compared to Visual Studio Code. And finally, integrate Terraform and GitHub on Windows machine using IntelliJ IDEA, combining everything. Doing in Windows machine is pretty straightforward, and people have done it today and have shared it in our group. So basically, in a Mac machine, what you will do is you have a package manager called Homebrew, and in Windows machine, you have a package manager called Chocolatey. And in Linux machines, you will have a package manager specific to that Linux distribution. Also, you can install Homebrew if you need. So if you come down here to this page, terraform.io/downloads, you have different options: macOS, Windows, Linux, FreeBSD, Open BSD, Solaris. You can just go to whatever operating system you have and then follow the steps. For Mac, I have just followed these two steps: brew tap HashiCorp/tap, and then brew install HashiCorp/tap/Terraform. And then that is it. Everything is installed automatically. Similarly, you can do it with the Chocolatey on your Windows machine, and Linux, you can use Homebrew itself. The advantage is that so later when a new version of Terraform comes, you don't have to go again and download and install. So here you have to just tell brew upgrade Terraform, and it will be upgraded to latest version. So installing Homebrew is also very straightforward. You can go to brew.sh and then you can install it. And as an optional assignment, you can prepare recipes for operating systems, for other operating systems and using a Docker container. Don't worry about it. So optional assignments, you don't have to complete. And then second, in case if you want to work with Visual Studio Code, VS Code, so it is a cross-platform tool available on Windows, Linux, macOS, etc. You can just go to the website and download. You can just Google. And once you install Visual Studio Code, you can go to this extensions icon, click on it, and then search for Terraform. You'll be finding a lot of Terraform related plugins here. I have used the one which is coming from HashiCorp itself, which is the second one here. The order could change. There is actually another one with better stars. I'm not use it though. I just stick to the official one, even though it has lesser stars. Okay, and then you can install, and that is it. You have Visual Studio Code with Terraform extension plugin installed. And now comes the important recipe where you will be integrating Terraform with GitHub. So as a prerequisite, you need to have a GitHub account. So we had a very detailed session on GitHub called GitHub 101, and it is available in the Trainso YouTube channel. You can just find it out. You need to have Terraform installed in your local machine, following the previous steps. In Windows, you can use Chocolatey, and in Mac and Linux, you can use Homebrew, or we can even do directly, but I prefer always using these package managers. And then one thing, what we did not discuss in GitHub is creating your personal access token. So you'll be contacting GitHub through APIs, not from a portal or not through your GitHub commands, right? So your Terraform will contact GitHub using APIs. And for that, you need to have a personal access token generated. So what you can do is you can just go to your GitHub, go to settings, and then you can click on developer settings. And then under developer settings, click on personal access tokens and just click on generate new token. And once you have your token, you can just copy paste. And while you create your token, you can give a note. So note is basically a name for you to recognize, okay, why you created this token. Then you can set a expiration date. If you want, you can revoke this token even before that expiration date. And then you give all repo permissions to do the lab. And optionally, if you also want to experiment with the Terraform destroy, then you can give a delete repo permission also. But if you are giving a delete repo permission, make sure your token is not misused, because it can eventually be used if somebody want to delete all of your repositories. If you want to try out and then revoke that token immediately. Okay, then finally scroll down and click on generate token. Personal access token should be created now successfully. And then you can copy paste, copy from here, then you can paste it in your Terraform configuration file. And for a Terraform configuration file, it is a very simple one file code that you have to use for your particular lab. First, you have to create a folder for doing the lab in your local machine and create a file called main.tf in that folder. And it will have these contents, and I have added it to my GitHub repository so that you can just copy paste from there if you want. Basically, it will have a few sections. So first one is this Terraform required providers section, which is mandatory, I believe, from Terraform version 0.13. All the one versions have them. Okay, so basically you are telling, okay, required providers, GitHub, and version should be of this form. And all these things you can get from Terraform website. Whenever you need to integrate a provider, just go to website and then copy paste this part for that particular provider. We will see for Azure, AWS, and all in coming classes. This provider block will have things that are specific to this provider. For example, GitHub will need to pass a token. There are also other ways you can communicate with or configure this by using environment variables and all. So we'll explore and experiment more, but to keep things simple, you can just replace this with your access token, and then you can use it. And then here we are only having one resource, which is a GitHub repository. I've given a name git repo from TF from Terraform. So this is just a name to identify this resource, but the name inside is important. Your repo will be created on GitHub with this name. repo created with TF. And you can provide a description, repository created with Terraform. And visibility, we have learned in our GitHub or Git 101 session, right? You can have public and private repositories. So we'll have a public repository so that you can share your assignment in the group and then others can also verify. Either you can look at it and type or just go to this URL and then copy paste. Okay, so now comes the important things. Okay, now I have used Visual Studio Code for all these screenshots and all. You can use any other IDE also. Okay, so as of now, I have created a folder called project1, and inside that I have only one file, which is main.tf. And if you go to terminal and run this command terraform init, the first command, right? First command, then what will happen? So it will basically initialize the backend. And then the most important thing is it will be initializing provider plugins. So we have only mentioned GitHub. So it will if first finding integrations / GitHub versions matching whatever we have given. It will find the latest one that is matching. In this case, it is version 4.28.0 and it will install it. And finally, it will initialize with a few other things that can help Terraform process the future commands. That is it. So now, if you go back and see, you will have a folder called .terraform where you have all this plugins details and all. And then you have a main.tf and then an additional log file. One mistake that people generally make when working with IDEs is that some IDEs will not save your file automatically. You'll have to manually save it. Otherwise, you will continue to run and then Terraform will not create any provider. Even when you go to Terraform website and then practice there also, you have to manually save. Otherwise, it will not work. Now, optionally, you can write format if you want, but I have formatted it good, so there was no change for me, but you can do it from the terminal. Now you can run Terraform plan. So when you do run a Terraform plan, it will provide you with this execution plan, and it will also give you this warning. You didn't use the out option to save this plan, so Terraform can't guarantee to take exactly these actions if you run Terraform apply now. I already mentioned that, right? So you can see if all the things are fine. So you can also use this just for seeing, okay, if things are fine or are there any serious changes. And if there are no changes, it will just tell that, okay, there are no changes. And in this lab, we have not saved it. We are trying to run apply again without the saved file. So what will apply do? It will do the execution plan creation, and then it will ask us, do you want to perform these actions? And then you have to say yes, and Terraform will complete. Like a proposal, right? Do you want to marry me? And then say yes, and then they get married. So similarly, so you can say yes, and then the resource will be actually created. And now if you see, it will have more files here. It will also have a file called Terraform TF state. This is the file where Terraform tracks your server's current state. Okay, so if you see here, it will have all information about whatever is configured on the server. And whenever you change anything, it will compare with this state. And then it will tell you whether there are changes or not. And now if you go to your server, you should be able to see the new repository created there. And even the count of repositories should increase. And finally, and optionally, if you want to delete the repository, and if you have given that delete repo permission, then you can run Terraform destroy. It will also ask you for permission. Okay, do you really want to destroy all resources? And then when you say yes, it will be destroyed. And if you go back to your GitHub account, you will not see that repository. Your repository count should decrease, and your state file also will not have much information because there is nothing to track on the server. You have destroyed everything. Okay, so you can read about these commands again if you want, but at the core, these 5 commands are the core of Terraform. Init, format, which is optional, plan, apply, and destroy. Okay, init you do once at the beginning. Plan and apply will be something that will be doing regularly. Okay, so one of the reason why this session is taken upfront is because whenever you are learning more and more about cloud, and whenever you are learning about ARM templates and other ways to provision, you can parallelly use this Terraform knowledge to actually provision those things using Terraform also. If you have Terraform in your resume, your value is going to increase just like anything compared to not having Terraform in your resume. And we have not covered anything specific to Azure Cloud or AWS Cloud or anything else today, because today I want you to go back, practice these recipes, and make sure you understand these things properly. And then we will go to further steps where we'll be exploring more and more deeper concepts and tricks and all from Terraform, especially from a multi-cloud perspective. And this document will be updated regularly, and I will keeping it in this heartin.cc website. There will be comments added below this video, whether it is available in a different place. Okay, so is Terraform basics clear for you?
How important is chocolatey? Like, can we just simply download the exe and keep it in a folder? Like, even that should work, right? Like, instead of downloading chocolatey, we can just keep the Terraform exe and work from that folder.
Yeah. So you can definitely work that way, but developers like to give away the responsibility of regularly updating and all those things to a different guy, right? So even if you are working with any UI technology such as Angular or React with Node.js, there also you have a package manager. You can definitely download all these things manually, but people only use package managers even there. So developers generally have this habit of using package managers extensively, and that is one reason I prefer it, but you can definitely do it without that also.
Yeah, thank you.
Because whenever you have a newer version, so in Homebrew, I have to just say brew, upgrade Terraform, and everything else is taken care. But otherwise, I have to go to that website, download, and then do all these circus.
Yeah, thank you.
So my question is it mandatory to install Visual Studio for this assignment?
So you can install either Visual Studio Code if you are comfortable with any other IDE such as IntelliJ, that is also fine. Because Visual Studio is a free IDE, and going forward, you will need it for many other labs also. So it is good to have.
So we need license for that, right?
No, it is a free product. So Visual Studio Code, I included because it is a free and open source product. I'm not sure whether it is open source, but it is a free product. Visual Studio is a paid product, and Visual Studio Code is a free product.
Okay, got it. Thank you.
Yeah.
Actually, I'm not from the development background, so I was not able to understand the difference between code and the Visual Studio.
Yeah, Visual Studio has subscriptions. Like there are 2 kinds of subscriptions mostly. One is professional and one is enterprise. With professional, you get along with the Visual Studio tool, you also get a $50 credit per month. And with the enterprise, you get a $150 credit per month on Azure to practice. But this guy is free, Visual Studio Code.
Okay, got it. Thank you.
I will expect each and every one of you to complete this lab. It is very straightforward, right? And if you have any doubt, just ask in the community group and you will get help. And once you complete, just mention in the community group also that you have completed. It will inspire the little lazy ones also. There is a question from Vishnu. Where did we give Azure credentials, etc. to connect to create the resources? Today's session, you don't need Azure credentials to practice. So today it is only GitHub. So everybody can create it for free. Today our goal is to understand Terraform. And the same commands we'll be using for Azure and other clouds also. We'll go one step at a time. That is good coaching to save the screenshots as well. The reason is because whenever you are going for an interview or whenever you want to do it, you will not be able to do these things again. Okay, and then if you will not even have time to go through a video, but if you have these screenshots organized like the way I have done, you can just scroll through it and then go for the interview, or whenever you have some doubt, you can only go to that particular note and then watch it and then do. It will really help both in interviews as well as for your work as a reference document. Practice always, ask doubts, and you will automatically become an expert. Okay, there is a question. Can we have PDF manual to perform tasks? Yes, definitely I'll share it with you. But do not share it with anybody else. Keep it only with you, because eventually I want to make it as a book. And if you have any feedback, or if you find even a spelling mistake or grammar mistake, whatever it is, please let me know that so that I can update it. Okay, everybody. See you in next class. Until then, happy learning and sharing.